Lesson 6.1 and 6.2, we are going to be solving and graphing inequalities. Earlier in the year, we talked about inequalities. Who can tell me what makes a problem in inequality? What does it have to have in it? Does anybody remember, Matthew?
A greater than or less than.
Very good. A greater than or less than sign. That's what our inequality would have in it, as opposed to what we've been working with, our equations. Let me give you an example of how they're different. If we had the problem 2x equals 12, if I wanted to solve for x, what would I do?
Divide by 2.
You would divide by 2, and x equals 6. This is an equation because for this problem, x can only equal 6. That's the only way it's a solution, because I can't have any other numbers. If I plugged in any other number, it would not be a solution. But when I have inequalities, there is a difference. Let's say 2x is less than 12. Now, in order to solve for x, we do not do anything different than we do when solving equations. So if I wanted to get x by itself, what would I do? Divide by 2. Still dividing by 2. And this time, x is less than 6. That tells me I can plug in any number at all for x as long as it's less than 6. I can plug in 5. 5 is less than 6. Is that a solution? Yes, it is. I could plug in 0. 0 would be a solution. I could plug in negative 10. I could plug in negative 1 million if I wanted to. As long as the number is less than what it says, or greater than, depending on what the sign is, that's how we know it can be a solution with inequalities. That's why when we have inequalities, we usually have to graph them on a number line so somebody can get a visual of what your solution will be. Whenever we are graphing inequalities, so let's take that same solution that we had in the last problem, x is less than 6, and let's graph it. Now, when we graph inequalities, we always graph them on a number line. So we're taking a break right now from the coordinate plane, and we're just dealing with number lines. When we deal with number lines, the way that I like them as a teacher is I like you to put the number that we are dealing with right in the middle. So I'm going to put 6 right here in the middle. And then I usually like you to do 2 numbers smaller than that value and 2 numbers larger. So I'm going to put 5 and 4, and then 7 and 8. You do not have to include 0 in your number line, okay? Because sometimes the number is very big that we have to do, or very small, and you have a huge number line if we had that. Okay, so just do the number that you need to deal with, and then 2 numbers smaller, 2 numbers larger. Let's look at what these definitions right here say. If we have a greater than or less than sign, we use an open circle over the number that I'm dealing with. If I have a greater than or equal to, less than or equal to sign, I use a closed circle or a colored in circle over the number I'm dealing with. This is the easiest way for me to tell you to remember that. If there is no extra line, don't color in the circle. If there is an extra line, like this extra line, color in your circle. It's one of the easiest ways to remember. So am I going to use an open circle or a closed circle in this problem? Open. And it's x is less than 6. So I need to shade the number line in the direction that the numbers are going less than 6. So is it going to be to the left or to the right? Which way are the numbers less than 6? Left. So we would shade our number line. Now, I just like to draw little squiggle lines. You could do this if you wanted to show me that it was going that way. You could color it in darker. Anyway, as long as I know, you know which way the inequality is going. Now, here's one thing about inequalities. When we're dealing with inequalities, the variable always has to be on the left side. I cannot say, if I ever gave you a problem like this, 3 is less than x. I want you to flip it around. I want the x to be on the other side. And here's the thing about inequalities that are different from an equation. Remember, equations, we could just say, oh, okay, since we're flipping both, we'll just say x equals 3 instead of 3 equals x. But when we have inequalities, if I flip sides, I flip signs. So if I say x and 3, I have to flip the sign. So it now becomes this. Because look at what it was originally. The open mouth is towards the x. It has to stay towards the x. So when the x moves, so does the sign. Does that make sense? So then when I go to graph it, I would say, okay, x is greater than 3. I draw an open circle over 3, shade every number that's larger. Also, when you write inequalities this way, okay, listen to this very carefully because here's a shortcut, but it only works if you listen to the rules of the shortcut. Anytime you have an inequality, as long as the variable is first, whichever way my arrow is pointing is the direction I shade. But if it is not first, for instance, if it was still 3 is less than x, that is not okay to just shade the way the arrow is pointing because it would be wrong. Since this is the same thing, my arrow has to go this way because it's every number greater than 3. But when it's opposite, it does not work. That trick does not work. Okay, so there's a shortcut, but there's some rules of the shortcut. The rule is the x has to come first. And if I change sides, I change signs. Remember that? Okay, so let's put this into practice now. We want to solve our equations just like we would any other equation. So I want to get x by itself. We want to solve inequalities. So what would I do to get x by itself? Bomnet?
You divide.
I don't want to divide because look what's happening between the x and the 5. What's happening there between the x and the 5? Adding. So what's the opposite of adding? Subtracting. Very good. So we want to subtract 5 on both sides. And now I have x is greater than or equal to, because I just bring my sign down. What's 3 minus 5? Negative 2. So now I need to graph this inequality. So I'm going to do my number line. We're going to put our negative 2 right here in the middle. And I need to do 2 numbers smaller than negative 2 and 2 numbers larger. So negative 3, negative 4 are smaller than negative 2. And negative 1 and 0 are larger. Remember, your number line always goes from smallest to greatest, left to right. So what type of circle am I going to have, an open or a closed? A closed over what number? Negative 2. So we color in our circle here. Now, which direction am I going to shade?
To the right.
To the right, because it's every number that is larger than negative 2. Okay, let's do the next one. What do you see that is the problem in this first problem here? Darius?
The variable is not on opposite sides.
Very good. The variable's at the back of the problem. So let's go ahead and flip our problem around. I want n minus 4 at the front, and I want negative 2 at the back. If I flip sides, I have to flip the sign. So now it's going to become, instead of greater than, it's less than.
Yeah.
So now what would I do to get n by itself?
Add 4.
Add 4 to both sides. Very good. N is less than 2. So let's draw our number line, and every problem has to have its own number line. This is not like a coordinate plane where we can sometimes put more than one. You cannot do that with number lines. So am I going to have an open circle or a closed circle? Open over what number? 2. And which direction am I going to shade? To the left. So the next example, okay, I have a divided by 3 is less than or equal to 12. How do I get a by itself? Multiply by 3. Perfect. So it cancels out here. I multiply over here. And I have a is less than or equal to 36. I draw my number line. What type of circle am I going to have? Open or closed? Closed over 36. And then which direction am I going to shade? to the left because it's every number smaller than 36. Now I need everybody to pay attention on this next example because here is a new rule. What would I do to get x by itself?
Divide by -2.
Divide by -2. When we are working with inequalities, anytime at all I multiply or divide by a negative number, I have to flip the sign. So if I started out with a less than sign, it is now going to be a what? Greater than sign. 6 divided by -2 is -3. That is a rule you have to memorize. If I multiply or divide by a negative number, we have to change the sign. Now, if it was like a greater than or equal to sign, I would still keep the or equal to part. It would just become less than or equal to. So you don't say, oh, well, I need to put the equal to sign because that's the opposite. No, we're just talking about the major sign. If it's greater than, it needs to become less than. Or less than needs to become greater than. Okay? So now we graph this. X is greater than -3. So write our -3, -4, -5, -2, -1. And what type of circle am I going to have? Open or closed? Open. And which direction am I shading? To the right. Okay, now we're going to be moving on. This is the 6.2 part of it, which we're still doing the exact same thing. The only difference is now we've got multi-step equations. So I'm going to have a couple different steps that I have to do before I can get x by itself. So Jacob, look at this problem right here. Tell me, what would I do first?
Add 3 to each side.
Very good. Add 3 to each side. 5x is greater than 15. Matthew, what would I do now? Divide by 5. And I get x is greater than 3. Did I need to change my sign? No, because I didn't divide by a negative number. So now I draw my number line. Am I going to have an open circle or a closed circle? Open. And which direction am I going to shade? To the right. Very good. Every number greater than 3. Amanda, look at this next problem here. What am I going to do to get x by itself? Very good. Subtract 5. You say, wait a second, how come I don't add 5? Because what is 5, a positive or a negative? Positive. So we have to subtract 5. Now pay attention. What number is in front of your x? -1. Don't forget that sign. Is greater than 4 minus 5 is -1. Stephanie, what do I need to do now? Divide by -1. Ding, 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 ding. There should be a bell going off in your head saying, what do I need to do? Change my signs. -1 divided by -1 is +1. So when I go to graph this, x is less than 1. Am I going to have an open circle or a closed circle? Open. And which direction do I shade? To the left. Very good. Okay, the next example. Same thing. We've just got variables on both sides now. At the beginning of the lesson, I told you which side should the variable always be on? The left side. So let's go ahead and move all of our variables to the left side so it saves us time rather than saying, oh, well, let's just do it however, and then at the end we'll switch it if we need to. No, let's just go ahead and do it this way. So if I want my variables to be on the left-hand side, Jasmine, what should I do?
Add 4x.
Is 4x positive or negative?
I mean, subtract.
Very good. We want to subtract 4x because 4x is a positive, so the opposite of that is a negative. 2x minus 4x is negative 2x minus 4 is greater than or equal to -1. Would I have needed to switch my sign on that step that I just did since I moved a negative number over? No, because I did not multiply and I did not divide. Just adding or subtracting does not change it. Only multiplication and division. So now, Naomi, what am I going to do?
You're going to add 4 to both sides.
Very good. Add 4 to both sides. Now I have negative 2x is greater than or equal to 3. Now what am I going to do? Divide by negative 2. Ding, 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 ding. What do we need to do? Switch the sign. So now it's x is less than or equal to. What is 3 over negative 2? Negative 3 over 2 or negative 1 1/2. Let's change it to a mixed number because that way it's going to be a lot easier to find on my number line. So I'm going to put negative 1, negative 2, negative 3, 0, 1. Where is negative 1 1/2, Clay?
Is like in between the negative 2 and negative 1.
Very good. Halfway in between the negative 1 and the negative 2. And what type of circle am I going to draw? A closed circle.
Close circle.
Okay, and which direction am I going to shade? To the left. Very good. It doesn't have to perfectly be in between negative 1 and negative 2, obviously, as long as it's close to the halfway point. It is correct.
Why did you change
Why did I change what?
like the sign?
I changed the sign because we divided by negative 2. So when I divide by a negative number, I have to change the signs. Okay. Morgan, what should I do first in this next problem?
Subtract 3x.
Very good. Subtract 3x. Because I want to get my variables on the left side. Alex, what's negative 1 minus 3x? Negative what x? 4x. Very good. Negative 4x is less than or equal to 21. Madison, what should I do now?
You would subtract 1 from this side.
Very good. Now I have negative 4x is less than or equal to 20. Anna, what should I do now? Very good. Divide by negative 4 on both sides. What do I need to do? Change the sign because we divided by a negative number. So x is greater than or equal to what? Negative 5. So now oops. I did my number line the wrong way. And you got to make sure that you pay attention because negative numbers, it's very easy to put negative 4, negative 3 on the left-hand side when those numbers are not smaller than negative 5. Remember, a number line always has to go smallest to greatest. So what kind of circle am I going to use? Closed circle. And which direction is it going to be shaded? To the right. Okay, this is your homework for tonight. And your exit ticket is page 343, number 25. Do that problem first, and then you will do all the other ones underneath it. Remember, use a number line to graph all problems, even when the instructions do not say to use a number line.